Hi, hello, good evening, friends. Welcome to my YouTube channel. In the previous classes, we discussed about the basic concepts of electricity, Ohm's law, as well as transformer. Now, today we will discuss about electromagnet. So, it is a concept related to magnetism. So, electromagnet is very simple concept, but yet it is very important to know and to discuss. Now, today's date is 21st May 2024. Right? Now we'll start the basic definition of electromagnet. Any conductor, if it carries current, or if the current is passing through any conductor, then the conductor starts behaving like an electromagnet. Now there is a lot of difference between to say a magnet or to say an electromagnet. So there is a lot of difference between magnet and electromagnet. Of course, there are different type of magnets available. One is a permanent magnet. The second one is what I am discussing now, that is electromagnet. Right? Now, in simple short form, the material which retains the magnetism property even in the absence of power supply can be called as permanent magnet. That means the withstanding capacity of the element or material is more, is of long duration. Whereas in simple short form, what is electromagnet? The material which acts as a magnet only in the presence of electricity. The material which acts as a magnet only in the presence of electricity is called electromagnet. But not only in terms of definition, but for the sake of saying about the characteristics also, there is a lot of difference between these two. Anyway, our main concept here is to know what is this electromagnet and basically how this is formed. Here the interesting point is to know that how this electromagnet is formed. I am just saying that when the current is passing through the conductor, then the conductor behaves like electromagnet. But how it happens? That what the things that are going to take place inside the material, that is very important. Now, let us take a small example of one conductor or a material. I should not say immediately it is a conductor. So, let us take a material, right, can be called as A and B. Now, since I am dealing with the magnetic materials, so I should speak everything about the concept only in terms of magnetic. Right? Now here I will be showing the magnetic molecules like this. So the shape of this magnetic molecules is not like uniform. It can be of any different structure. Right. Now, you may ask a question, why these are drawn inside this material? So, this is a material having the conductivity. Now, if you remember the earlier class, or basic concept, I don't feel that, I don't take it for granted that you have seen my earlier video, but it's a normal basic thing that inside the material, what we have, material is made up of molecules, and molecules are made up of atoms, then if you know the atomic structure according to Niels Bohr principle, then we can easily assess the performance of the material or characteristics of the material. And also we can say whether it is going to behave like an insulator, or it is going to behave like a conductor, or it is going to behave like a semiconductor. Similarly, when you speak about the magnetic materials also, we should speak in the same manner, right? On that day I told that in the absence of power supply, the number of electrons is equal to the number of protons inside the atom, right? That means the net charge of the atom is zero in general when no supply is connected. Now when there is a supply connected to the material, then only there is some disturbance in the number of protons and number of electrons. Of course, number of protons will never change, but there is some disturbance in the number of electrons because there is a movement of electrons from one point to another point. So because of this disturbance, sometimes it behaves like a positive ion, sometimes it behaves like a negative ion, and so on. So similarly, here also we have to assess the situation in a similar manner. Like in case of electric terminology, in case of electrical terminology, so what is electrical terminology? In case of electrical terminology, we are calling it as protons and electrons. So the charge of the proton is positive, okay, and the charge of the electron is negative. Similarly, in case of magnetic terminology, so in case of magnetic terminology also, we have few things to know. So one is north pole, and the other one is south pole, right? I am just comparing just so that you will understand clearly. In electrical terminology, there are protons and electrons inside the material. The charge of the proton is positive, the charge of the electron is negative, and both are having same charge. What is the charge? Minus 1.602 into 10 to the power of, sorry, it is 1.602, but the sign will depend upon the type of material, type of ion. So it is plus or minus. Okay, that means when the value is same, what is the meaning? Magnitude is same. So when the quantity value or the magnitude or the amplitude or the strength is same, I can say that these two are having, same force. They are having same strength. In the similar fashion, when it comes to magnetic terminology, we have north pole as well as south pole. Similarly, here also, the north pole and south pole both are having same strength. The north pole and south pole both are having same strength, but they are equal and opposite, like here. Here it is plus or minus 1.602 to the power minus 9. That means both are equal and opposite. Similarly, here also the strength of the north pole is as equal to strength of the south pole, but the only thing is they are opposite to each other. That means the net strength of the north pole south combination, the net strength of the north and south pole combination is 0. Like here, the net charge of the proton and electron in an atom in the absence of power supply is 0. Similarly, here also, the strength of the north pole, and the strength of the south pole, same, but opposite. Same, but opposite in nature. As I am saying that there is the net charge in the atom when no power supply is connected is 0. Here similarly, the total strength of the north and south pole combination is also 0 because both are having same strength but opposite. So they have equal and opposite strength. Now this is what the scenario. Here I am just erasing this. Hope you are following. So here I have taken a material. So here I'm having a switch and a power supply is connected. It is plus and y minus. It is a battery or V, some voltage. It is irrespective what is the value to indicate. Okay. Anyway, the strength of the voltage also matters a lot to know the what we call the changes that are going to happen inside the material, right? Now assume that switch is open still. That means this material is not connected to power supply, right? In this material I have magnetic molecules like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So I'm just an example. Don't restrict these to only 11. It is only an example. So in my example, the material what I have chosen is having 11 magnetic molecules. These are called magnetic molecules inside the material. And what is the nature of these magnetic molecules? They are always closed paths. The shape of the magnetic molecule is random, like an amoeba. But whatever the shape may be, but the nature of the magnetic molecule is closed one. It's a closed path, right? Now here, each and every corner of this one, I'm highlighting it. It's very, very important because there only the actual concept is existing. Right? So even though they are like closed parts, but they are not in circle form. They are not in circle form. That is also important to understand. They are not in circle form. They are in the form of, like a triangle or rhombus, something like, in terms of uneven sides, with uneven sides. Here, so this is north and this is south. I think it may not be visible because it's very less font. This is north, this is south. This is north and this is south. North, south for one side. For this side it is north, south. For this side it is north, south. You are starting from north and you are ending with again south. Similarly, it is north, south. For this side, it is north, south, and north, south. Right? Similarly, I am writing for everything. So at each and every point we have NS now, right? So I am blindly writing at each and every corner, whatever the shape may be, at each and every corner there is a combination of NS, that is north and south. So I think I can straight away go ahead like this. Okay. So anyway, I think it is looking like clumsy. I'll take only 2, 2, 3. So don't mind. I'm rubbing it. I'll take only 2, 2, 3 for your easy understanding. So because if I want to show the each and every corner indexing, it is becoming clumsy. So let me take only 2, 2, 3. Right? don't think that why I am writing only like this. Only for your understanding. I'm once again saying it is only for your understanding. So I have taken 6. So it is north, south, north, south, north, south, north, south, north, south, north, south, and north, south. I think even now also it is somehow looking clumsy. Please don't mind. Please accept my pardon. Right? So at each and every corner you have north and south pole combination. Now, when no supply is connected to this material, what is happening inside? So at case 1, that switch is open. S is open, that means voltage is equal to 0. There is no power supply connected to it, right? When there is no power supply, as I told you, the magnetic strength of the north pole is same as the magnetic strength of the south pole, but opposite in nature, right? That means they are equal and opposite forces acting on a particular body, right? Now here, if I combine these two, since both are having same strength, I think the strength is here is 0. The overall magnetic strength, the net magnetic strength is equal to 0. Nil. Here also nil. I'll show only first triangle. Here also nil. Here also nil. Right? Similarly, in all the remaining magnetic molecules also, the overall magnetic strength is 0. Got it? Now, what happens if power supply is connected? So here, the net magnetic strength is equal to 0 or nil. Now in case 2, S is closed, so V is V volts. So I connected some voltage. Now. The things will change. So things will change. We'll see what going to happen here. Here it is north south, right? Now, when power supply is connected, so current passes, right? Here MMF is produced. So what is MMF? Magneto motive force. It is MMF, alright, and that is equal to number of turns into current, and the unit is ampere turns, right? N into I. So what is N? I said it is a material. Basically, magnetic property is more in terms of solenoid type materials, where we have number of turns or number of woundings or number of times it is wounded. So when the wire is wounded for number of turns, and if it is connected to power supply, I no need to show here the number of turns. Just I am trying to explain what is the reactions that happen inside the material, right? Think that magnetic property is more in wounded type materials, right? So if number of turns like this, if you say that if this is my conductor, a straight conductor can be wounded for number of turns, will become solenoid, right? If this is so, when this carries a current and the number of turns 1, 2, 3 and so on, let me take it as n. Here some kind of force will be developed, that is called magnetomotive force, like EMF we see in electrical terminology. Electromotive force, the force behind which, the force behind the motion of the electrons. A force is required to drive the electrons. Similarly, here also a force is required to break the bonds between the magnetic materials, bonds between the magnetic molecules, Here it is going to break the ionic bonds. Similarly, we have magnetic bonds, or magnetic molecules tied together in terms of, in case as like a closed loop. These closed loops are to be disturbed, or to be distracted, or to be broken with the help of a power supply. So when voltage is connected, this will drive a current into the material. When the current is driving into the material, it forms a magnetomotive force, which is nothing but a driven force to break this magnetic molecule bonds. Then what happens here? Here, as I told you, north and south are both are having same force. Like, see, if two people are having same strength, and if they are holding like this, see, this is one person, this is another person, both are having same force. Now if they are, one is pulling, both are pulling this object to opposite sides, this will not have any movement. The displacement of this material is zero. The reason is, this person and this person both are having same force and applying the same force on the body, both are having same strength. When same force is applied on a body on equal sides with opposite directions, then the net movement of this material or object is zero. So similarly, in normal case, when no supply is connected, this bond cannot be broken because there is no force. Now I connected the supply, that is case 2. Now there is a force produced in the material, that is called magnetomotive force. Initially I told you, I'm not writing any value for voltage, but value of voltage also matters a lot. Since these two are having same strength, the voltage is to be sufficient. The voltage applied to the material is to be sufficient such that will develop the required MMF. Why? Because this voltage is only developing this current. The current value, or the magnitude or amplitude of the current, depends upon the magnitude of the voltage applied to the material. So when the voltage is more, current is also more. When the current is more, since number of turns is constant, that means in this formula n is constant, therefore the MMF value is purely depending upon current value. That means simply MMF is directly proportional to current, that the current is flowing through the solenoid or conductor. Okay, so therefore this voltage value also matters a lot, such that the voltage value is to be selected in such a way that the MMF should be enough to break this bond. Why I am insisting very number of times breaking of this bond means both are having same force. So when both persons are having same force, breaking that bond is very difficult. So this should have the enough strength to break this bond. So think that somehow you have given the voltage which is sufficient, and you got the MMF sufficiently, and this MMF has broken the bond. So now let us assume here the bond has been broken. If this bond is broken, what happens? See this. Here it is a break. Now north will come here. This is north, right? After north, what we have? South. Then it is a one point, okay, one meeting point. So it is north, south, as well as north. Then next one, it is another second point, meeting point, south, and immediately north, and then finally this south. So please closely observe this. This one you should observe it. Initially, it is like a triangle, right? Now this has been broken. This has been broken. So it is north, south, north, south, north, south. This has been broken. Now I am stretching this like a straight line. I am stretching this like a straight line. Now north has come to one side and south has come to other side. Now as I told you, wherever the combination of northern pole is there at a single point or at a single location, then at that point the total net value of the magnetic strength is 0. Here also 0. 0, 0. But it is not 0 because they are not a combination of north and south. One north is other side, south is this side. North is left side, south is right side. Therefore, there is no combination. They are at different places. They are part away. So north is left side, south is right side. Now this is going to happen with all the things. Why? Because MMF is going to break the bonds of all the magnetic molecules. Therefore, suppose if this is a break, now this will be like a line. If this is a break, somewhere it is broken. Not at all. Even if we ask a question, if all the bonds are broken, what happens? All will be like this, like this only. You may have a question. Sir, you are saying that breaking of bond is only at one point. No, it may have at all three places also. Think of that. If all three places are broken, what is happening? North south 1, north south 2, another one north south 3. So all these three will be aligned like this. One side north, the other side south. Okay. So similarly, this happens with all the things. Then finally, think that if all the magnetic molecules are with broken bonds, then what will happen here? All the north sides will come at one point, right? So I am just taking 5. I think initially I have written 6, I think so, but whatever it is, think that it is like a triangle earlier, it is like a rectangle earlier, it is like hexagon earlier, like a rhombus earlier, right? Like that. So except the place where the bond is broken, at remaining all places there is a combination of north and south. Therefore the net strength is 0. But where the bond is broken, that only will be separated. Like one is one side is north, the other side is south. So think that these one side all got north polarity, the other side got a south polarity. Now in simple language, simply this will become a magnet. How do we indicate a magnet? Generally, when someone is asking you to draw the magnet, means how do you do? How do you represent it? Just draw like this, like this. If someone is asking, yeah, this is north and this south. The same thing I am showing here. It's a magnet, right? Now, summing of all these north magnetic molecules and summing of all these south magnetic molecules will become a single north at one side and single south at other side. So therefore, this conductor, because power supply is connected now, plus and minus V. So one side is north, the other side is south. It doesn't mean that they are ready to attract the materials. Magnetic property, this is not permanent magnet, it is actually electromagnet. So this will act like a magnet only when the power supply is connected. When I am saying that it is acting like a magnet, it doesn't mean that it is going to attract the iron material. No, it's not so. It is going to produce the electromagnetism, but the capacity of the electromagnetism or the strength of the electromagnetism is very, very little one. The reason is the material with which it is made is also so. Because for permanent magnet material, for making the permanent magnet material is different, which have high residual coefficient, and they have more property to retain the, they have more strength to retain the magnetic property. Okay, since I am talking about the electromagnet, these material will act as a magnet only in the presence of power supply. So once I remove the power supply, again the same thing will happen, that like all the bonds again will form, like one is square, the other one is a rhombus, one other one is a triangle, like I have shown. I am not saying that they are going to form like a what we call the structure like what I have shown. They may be of different type, but they are closed, right? Now this will act like a electromagnet, and once the supply is removed, it will again behave like a normal one without any magnetic property, because all the bonds again will go and join. Whereas in permanent magnet, this will be there. The bonds will not, once the bonds are broken, they will not again form like a closed one. They will sustain like that only. They will retain its property like that only. That means for a longer time, one side will become north, the other side will become south. Then, what is there in the middle of these two? What is in the middle of these two? Nothing. The strength of the magnetic material in the presence of power supply, and if it is called as electromagnet, in the midway or between north and south, there is no property, there is no magnetic property. That is the reason, if you suppose if this is your electromagnet, it is north pole, it is south pole. In between these two, there is no property. The property exists only at the terminal spot. That is, here north pole is there, here south pole is there. That means the strength is only at the edges. Let us take a small sprinkles of the iron, some teeny particles of the iron material. If you pour the iron material on this magnet, think it is a permanent magnet. We will see electromagnet later. If it is a permanent magnet, if it is north pole and if it is south pole, if you pour that teeny particles of iron material, like powder type, then or little bit having diameter or radius, not like completely powder. So if you pour that material on this permanent magnet, that material will try to attract only at the edges, but not in the middle. The reason is, here the strength is zero. There is no property. Those particles will be attracted only either left side, not either, both the left side as well as right, because the property lies only at the edges, whether it is an electromagnet or a permanent magnet. The only difference between these two is the amount of time or the duration about which they retain their property, right? So this will happen in case of electromagnet. Once the power supply is removed, again it behaves like a normal material. There is no difference. There is no property at all. The type of materials which are used for designing the permanent magnets or electromagnets are different, depending upon the material only, and depending upon the conditions where they are going to use. That will decide the type of material and the property also. So there is a lot of difference between these two. I hope you understood the concept. If you understood the concept, please like, share, comment, and subscribe to my channel. And also please press the bell icon so that you will come to know, or you will be prompted as and when I upload the video. Please share this channel to your known contacts and support the channel for its upgradation. Thank you all. Thank you and good night.